Hi, and welcome back to EduHub Academia, the Education for a Better Future platform. We will continue our course, The World of Physics, lecture number 7 about optics. Now, what is optics? It is that branch of physics where you can study the various natures of light, how it behaves, and how it interacts with different media of matter. Now, light is a form of electromagnetic radiation that is visible to the human eye. We can see it. We can see objects through it. It can behave as both a particle and a wave, and that's why we say it has a dual nature. It consists of particles called photons. So this is where we talk about particle nature. And those photons are massless and they travel in waves. Now, light can travel in a medium, and also it can travel in empty space, which means the vacuum. Its speed in vacuum is about 300,000 kilometers per second, which is about 1 billion kilometers per hour. Now, in light, we talk about mirrors and lenses. Mirrors where we have reflection and lenses where we have refraction. Let's begin with mirrors. Mirrors are smooth, polished surfaces that can reflect light. And there are two types of mirrors. First type, the plane mirror, the flat mirror. It's smooth, it can reflect light to produce an image behind the mirror, and that's why we say it's a virtual image. Now, mirrors follow the laws of reflection, and these are as follows. The angle of incidence I, as you can see in this diagram, equals to the angle of refraction. The angle of incidence I equals to the angle of reflection R. On the other hand, the incident ray AO coming from a luminous object, from a luminous source, the reflected ray OA prime, reflected by the flat mirror, and the normal, which is an imaginary perpendicular line to the mirror, all lie in the same plane, which is the plane of reflection. Now, what are the characteristics of the image phone P prime A prime of the real object PA in a plane mirror? If you stand in front of a plane mirror, you can see that you will have the same size. The image will have the same size as the object. It's virtual behind the mirror. It's erect, which means it's not upside down. It's at the same distance from the mirror, and it is laterally inverted. What we mean by that is that when you look into the mirror, your right hand will appear as your left hand, and so on. Now we come to spherical mirrors, not flat mirrors. And there are two types. The concave mirror, which is a mirror with curved inward, as you can see in the diagram. It's a converging mirror because it converges incoming parallel light rays to a focal point, F. It is used in various applications, such as shaving mirror, reflecting telescope, and headlight. The other type of spherical mirrors is the convex mirror, which is a mirror with a curved outward surface. It's a diverging mirror because it diverges incoming parallel light rays. The rays do not go through this convex mirror. Instead, once they hit the curved mirror, they reflect back, they bounce back as if coming from a focal point, which is an imaginary point in this case. Now, those mirrors, the convex mirrors, are used as safety mirrors in parking lots, in supermarkets, and side views of mirrors. They provide a wider field of view but sacrifices image size and detail, which means you don't get the exact image size or the details. Now we come to lenses and refraction. Lenses are transparent optical devices with curved surfaces that refract or bend light. So refraction in this case is the process of light changing direction as it passes from one medium to another of a different optical density. It bends as it enters another medium, or we say it refracts, it changes direction. There are two types of lenses. The convex lens, which as you can see in the diagram, it's thicker at the center and it converges light rays. They can form a real or virtual image depending on the object's position relative to the lens, and they are commonly used to correct farsightedness, hyperopia in cameras, also in telescopes and magnifying glasses. On the other hand, we have the concave lenses. They still refract light, bend light, but they are thinner at the center and they diverge light rays. Light rays do not converge to one point, instead they go away from the focal. They always form virtual images that are smaller and upright, not inverted, upside down. What are they used for? They are used to correct nearsightedness, which is myopia, in eyeglasses. Thank you very much. Hope to meet you next time.